Alright, so we're going to go ahead and start and talk about physical and chemical properties and changes. Why? Because we've talked about physical and chemical properties in minerals, and it's going to be really important as we do physical science to understand the difference. So the property is the description of an object, right? We'll say that it's green, it's tall, it's blue, it's rubbery, whatever it is, it has a property. If it's struck by lightning, it could catch fire, it's flammable, it's volatile, it turns into a gas. So physical properties are determined by the use of blank, blank, and there are the blank of an object, right? So what does that mean? They're determined by the 5 senses, and they are the description of an object. So when we're talking about a physical property, we're describing physically what does it look like, what does it feel like, what does it smell like, what does it taste like, what does it sound like, right? Some examples of physical properties: color, smell, taste, right? All make sense. Hardness, right? And we've seen this with minerals. States of matter, whether it's normally in a gas, liquid, or solid state, or maybe even plasma. Boiling, freezing, or melting point. So if you didn't know, all things have a point that they will boil at, that they will freeze at, and they will melt at. These are part of their physical properties, and it helps us to identify them and how pure a substance is. Some examples of them could be density, mass, volume, malleability, and solubility. So example, we know that gold is gold because it has a specific density. It's something like, I used to have the same lights. But mass and volume, those aren't really necessarily, you could have the physical property of something that's always a certain mass or always a certain volume, but the nice thing about density is it combines both of those. But sometimes you might have, a 2-liter bottle, and it has 2 liters of volume, right? That is its physical property. Depending on what it's filled with, it might have different densities, right? Or what it's made of. Malleability, we talk about that with metals. Metals can be molded. Solubility, whether it's going to get dissolved. Chemical properties are something a little bit different, right? Here we're talking about reactivity, whether something is going to change into something new when they're introduced. A flammable is reactivity. Anytime a chemical reaction happens is reactivity. So when you have a substance's ability to react with other substances, then we're talking about the chemical property. Examples of chemical property is maybe the ability to react with air, or maybe whether it's going to rust, or maybe whether it's going to tarnish, right? And we see this happen a lot with certain metals, right? And really, when you react with air, sometimes you are rusting, sometimes you're tarnishing. You might corrode, which is kind of the same idea, and these things break away. You might rot. And if you're rotting, that's a chemical property, but it means that you have the ability to rot, depending on what you're involved with. You might have a reaction that happens when you're in the vicinity of water or acid, or you might even be able to catch fire, which is called flammability. So these are just things that might be a chemical property. So when gunpowder is firing and exploding, this is a chemical property because whenever something combusts, we're talking about something that is a chemical reaction. You may not think of fire as a chemical reaction, but it always 100% is. So, what do you think the color of the sunset is? Hopefully you've answered in your own mind. The color of the sunset is something we describe with our eyes. It is a physical property. What about the ability of a nail to rust? What's happening there? Okay, whenever you rust, you're being oxidized, so that is a chemical property. Physical chemical property, the shape of a leaf, right? So we're looking at it, we're identifying it, and this, it still can be there, is a physical property. It's not talking about reactivity. About the fact that wood can burn, chemical property, because combustion is a chemical property. Combustibility, flammability. The hardness of a diamond, I'm talking about this, it's a physical property, because we're talking about something we measure. It's not about it changing. A diamond is what it is, and it's not necessarily very reactive, right? Or if it is, that's not what we're describing. The volume of your Coke, as we talked about this, is a physical property. It's coming in a 1-liter bottle, maybe it's coming in a 20-ounce bottle, it might change. The mass of 2 camels, as we discussed again, these are their physical properties. Now, these physical properties might change depending on which 2 camels you're talking about, which is why often we might use density when we're describing a substance, because it doesn't matter how much of something you have to know its density. A change that occurs without changing the identity of the substance is really when you're talking about a physical change. So you can make something smaller, right? and it still has the same physical properties. So you can have a physical change. You can melt something. You can melt ice, and it still is water, right? It's just you haven't chemically changed it. So it can change in size, shape, color, such as pencil shaping, form paper, crushed ice, sugar dissolved in water, painting, right? These are still existing because you can separate them out without a chemical reaction, which we can maybe cover later. And what we have to understand is chemical changes is really you have changed what it is. It is no longer what it is. It's a change that causes the identity of something to change. So we used to have carbon dioxide. It went through photosynthesis, and now it is CO2. You used to have wood, and you burned it, and now it's made of CO2 and water vapor, right? And this is when something new is being formed. New substances with new properties are formed. So, right, you will have new physical and chemical properties potentially when you have created a new subject. This is how we identify and know what things are. So, how do we know, right, when a chemical change happens? We can have color, we can have bubbles or fizzing, right? So the production of a gas is often what we're talking about there. And that's a phase change, right? That's something that used to be maybe in a liquid form, now we're seeing bubbles, so it's completely different because it's new. Precipitate form, so it's a solid that might form in the bottom, right? And you can see that right here. You might have heat being produced, you might have light and sound being produced, and you might be like, it's really difficult to reverse. All chemical reactions in theory can get pushed back, but you might have to put a lot of energy into it. So usually when you're doing a chemical reaction, they go from high to low energy, right, in terms of what potential energy is in there. So that means that you'd have to equally put that energy in to get it back in the other direction. So whenever you're looking for that a chemical change has happened, color, bubbles, precipitate, heat, light, sound, right, energy is given up. And then they're really difficult to reverse often. So reactions with acid, vinegar and baking soda creates a lot of carbon dioxide gas and some water and some leftovers in the bottom, right? And we have bubbles, we have phase, right, phase changes. We have the gas being produced, right? Oxidation, we have the iron rusting here, and this is why the dirt all around New Mexico in certain areas might look red, because they have a lot of iron, which is oxidized, right? Reactions to electricity, right? Here we have things that react to electricity, and you see that they have changed, like silver plating. You're able to go ahead and add it on there. Yes, we don't really, we haven't covered a lot of reactors with in generally speaking. We have sodium and chloride, which is salt, right? Silver and sulfur in the air, tarnish. So when you mix these together, we're getting something new. NaCl would be the new thing that we get. When we add silver and sulfur to the air, and you mix them together, it starts to tarnish, which is this off-color change. So, whole bunch of things. Food, other examples of chemical changes. Wood burning, metal rusting, food digesting, gas burning, cake baking. Anytime you're getting something that is new and different from what went in. When water evaporates from the ocean, think about it. What's happening to it? It's still water, right? Probably physical change, right? Because it's not changing. The yolk of an egg, which contains sulfur, causes tarnish to form on the silver, right? So that sulfur is reacting with the silver to lead to a tarnish, and that tarnish is no longer silver. It's not silver. It's something different, chemically speaking. Ice on a lake becomes water in the lake, right? It's a phase change, physical. Charcoal on a fire turns to ash after several hours. It's different. It's no longer the same thing. It has new physical and chemical properties, right? A pencil is sharpened in the pencil sharpener, leaving behind the shavings. Physical. It's still made up of the same things. It's still going to have the similar properties, density and whatnot, but it's different, right? A battery makes electricity to turn light, creating light. Right? So this would indicate that there's probably a chemical change that's going on here as a result. And as those electrons move through the battery to produce light, we are having some sort of chemical reaction. Rust, we've covered before. It is a chemical reaction. A shirt is actually torn in the washing machine. Physical. A log is split in two. Physical. Now, I went through some of these pretty quickly, right? But I need you guys to understand the difference between physical and chemical changes, because mainly we've been talking with minerals is there's two different types of changes, and I want you to really, or ways to identify them, and I really want you to think, oh, we're looking at physical properties Or are we looking at the chemical properties? Generally speaking, we have been looking more at the physical properties. All right.